This is Chapter 7, Section 5, Where Shipping Out, Solving and Graphing Inequalities in One Variable, and I'm starting on page 374. So go ahead and turn to that page in your book, and I'm going to start out on number 1. Aaron wants to buy new football pads that cost $55 at goodsportsbuys.com. The online store charges $11 for shipping on orders less than $75. He is also considering buying ski gloves, but he does not want to pay more than the $11 shipping fee. Write and solve an inequality that describes the possible number of additional dollars Aaron can spend and still remain in the $11 shipping fee category. Let D represent the additional dollars. Explain your situation in terms of the problem situation. Well, here's the additional dollars, D, that Aaron might spend on gloves, plus the $55 that his football pads cost, and that total needs to be less than $75 to stay in the $11 shipping. We can simplify this just the same way we did with our equations by doing inverse operations over the opposite operations. So here our variable D is being added to 55. We need to do the opposite and subtract 55. We need to do it to both sides. So if we subtract 55 from both sides here, it's going to cancel out. We're just left with D needs to be less than $20. So in order to pay the $11 shipping fee and keep his order less than $75, Aaron can only spend an additional $20. Go ahead and read the next paragraph where it talks about solving an inequality and try number 2 on your own. When you're ready, press play. After reading this paragraph, you should have gotten out of it that solving an inequality is basically the same thing as solving an equation. We want to get the variable all by itself on one side by using the inverse operations. So to solve this equation, we would add 2 to both sides. Here it's going to cancel out, so we're left with 3x equals 9. And then the next step is to just divide by 3 to both sides, because again we're trying to cancel it out. So we're left with x equals 3. Okay, so you're solving inequalities the same way that you solved equations. For number 3, A, B, and C, they want you to circle the solutions that make the inequality true and then list 3 other solutions that fit the inequality. So first you have to solve the inequality just like we did with the equation before. So our inequality is 3x minus 2 is greater than or equal to 7. So in order to solve, remember we have to work through our order of operations backwards, which means take care of any addition or subtraction first. So here the opposite of subtraction is addition. I'm going to add 2 to both sides. I'm going to cancel out on this side. I'm left with 3x is greater than or equal to 9. And divide by 3 on both sides. We're left with x equals 3. This means that we can plug 3 back in to the x on this side. So if we plug 3 in, 3 times 3 minus 2. 3 times 3 is 9, minus 2 is 7. We need to find an answer that makes this statement true. So any value that we plug in for x, and this one we plugged in 3, for any value we plug in, it has to be greater than or equal to 7. So 3 works because it comes out equal to. We need to circle the ones that you could also plug in to x to keep the statement true. So try plugging in some of these numbers, see what you get, and then you also need to list 3 additional solutions. And I just realized I needed to keep this as a greater than or equal to, if that helps. So your x value needs to be greater than 3 or equal to 3. And we already found out that 3 works. So any numbers greater than 3 or equal to 3 works. So come up with your additional 3 and then try B and C on your own and come back to check your answers when you're done. Here are your answers for B and C. You should have gotten that each of them come out to be x is greater than or equal to 3. So all of the variables you could have circled or all the numbers you could have circled to plug in for x were 3 or anything bigger than 3. And then make sure that you listed any 3 additional solutions. So anything greater than 3 would have been a possible solution. Go ahead and try 4, 5, and 6 on your own, and when you're ready, press play. Number 7 asks us to graph the solution for 3x minus 2 is greater than or equal to 7. So first we need to solve it. We need to add 2 to both sides. And we've done this one before, so we should know what the answer is. Oops. Comes out to be x is greater than or equal to 3 because we divide both sides by 3 here. Greater than or equal to, when it has that little line under there, that means it could be equal to the number. So this man over here says, use a number line to graph this inequality. Remember, there's a difference between a closed circle and an open circle. On this graph, they've used a closed-in circle because the value or the solution could possibly be equal to 3. So 3 is included in our set. And then we draw the arrow all the way to the right and say that it goes on forever and ever and ever by adding the arrow at the end, because anything greater than 3 would make this solution true, or make this inequality true. If you had an answer like x is less than negative 2, that means negative 2 is not included in the solution set, so you would have to draw an open circle around 2 and then show anything less than 2. So the open circle and the closed circle are totally different. Make sure that you pay very close attention to whether or not you're leaving your circles open or closed. Next, it says you can check your solution to an inequality by choosing a value that is in your solution set and substituting it into the original inequality. All that basically says is you can pick any of these numbers, 3 or anything bigger, and plug it back into this original inequality. So we could pick something like 6, 7, 8, 9, 10, plug it in for x, and if the answer comes out true, then we know that we've solved it correct. So 8 wants you to choose a value from the solution set. So again, any of these numbers bigger than 3, plug it in for x, and verify that it is a solution. So go ahead and try number 8 on your own, and then press play. So here's my 2 examples. I chose x equals 3 and x equals 5 and plugged those into the equation. If I chose 3, I got 7 is greater than or equal to 7, and that's true. 7 is equal to 7, so that one works. And then I also plugged in 5 and got 13 is greater than or equal to 7, and 13 is greater than 7. So make sure that your answer is checked out. Then I want you to go over to page 376 and try number 9 on your own, and we will be checking that one in class. So when you're done, we'll be starting on problem 2, page 377. So do number 9 on your own, and then press play. All right, we are on page 377 now. Make sure that you did problem 9, and we'll be checking those answers in class. Problem 2 asks you who is correct. There's 2 different situations going on here. Both students tried the same problem. The inequality is negative 4x is less than 20. So they went through and did their inverse operations and both got an answer of negative 5. However, Brendan says x is less than negative 5, and Jenna says x is greater than negative 5. Jenna also wrote, I know that when I multiply or divide any given number by a negative number, I have to pay attention to the sign of my answer. So when I divide both sides of an inequality by -4, the inequality sign should reverse. So Jenna switched her sign because she divided by a negative number. Number 1 in your book wants you to check each solution and determine who is correct. List 3 values from each person's solution and verify that these solutions make the original inequality of -4x is less than 20 true. What do you notice, and explain your reasoning? So go ahead and try a few of each problem and then tell us who you think is correct and why you think you're correct. And then when you're ready, you can go ahead and press play. Here are some examples that I did. For Brendan's, I plugged in -10, -8, and -6, and came out with 40 is less than 20, 32 is less than 20, and 24 is less than 20. None of those work. For Jenna's, I plugged in -3, 0, and 5, and got 12 is less than 20, 0 is less than 20, and -20 is less than 20, and all of those work. So we should have found out that Jenna's solution is correct. So here we find out, let me get a highlighter quick, that it is necessary to reverse the inequality symbol when multiplying or dividing both sides of an inequality by a negative value. This is extremely important for you to remember. Okay, you need to switch that inequality symbol whenever you multiply or divide both sides by a negative number. If you have a highlighter with you, you should probably highlight that in your book. All right, I'm going to move on. Number 2, I want you to do on your own. It just says to circle the correct solution. We said that Jenna's is correct, and then cross out the incorrect solution. I will show you how to do this first one on number 3, and then I'm going to let you do the rest on your own. It just wants you to solve each inequality and then graph the solution. So here I am trying to get 8 or x all by itself. X is being multiplied by 8. Opposite of multiply by 8 is divide by 8. I then need to cross those out. I'm left with x is greater than 2. When I go to graph it, I make my number line. 0, 1, 2, 3. Okay, so x is greater than 2. So I need to think to myself, well, here's 2. Do I need an open circle or a closed circle? Am I including 2? And we should think, no, I am not including 2, so my circle needs to stay open. Okay, if I were including the 2, I would need to have that little greater than or equal to line down here at the bottom. So since my x is greater than 2, I need all the numbers on the right-hand side, or the ones that are larger than 2. So go ahead and try B through F on your own, and we will check those in class tomorrow. Once you finish those problems, you are done for the night. So have a good weekend.